Okay, are these linear or quadratic? So we're just looking at some equations here. Now, if it's a quadratic relation, it always has a degree of 2, meaning you're looking for that x squared. You need that 2 up there. So which of these are quadratic? Well, let's see. Y equals x squared plus 1. The degree of this equation is 2, so this indeed is quadratic. My next one is y equals 2x plus 1. Now we can assume there's a 1 here, which would make this a degree of 1. So that is linear. 3x squared, it has a degree of 2, so this is quadratic. X squared minus 7x plus 4. The degree of this equation is 2, so it's quadratic. Six x, the degree is just 1. That makes this linear. And a half x squared, there's our degree of 2, so this is quadratic. So they're quite easy to spot. Now the graph of a quadratic is a parabola, and the graph of a linear relation is going to be a straight line. Okay, here's some new terms. The vertex, we're going to call this the point at which the parabola changes direction. So if I had a parabola that looks something like this, and I'm looking for the point at which it changes direction, well, it's going down and then it's going up. So the vertex is that point right there. If we looked at a parabola that was opening downwards, again, the vertex is the point at which it changes direction, so it would be this point here. You can also call it the highest or lowest point on a parabola. This would be the lowest point. These arrows mean it goes up forever, so the vertex would be there. And this would be the highest point of a parabola opening down, so the vertex would be there. An axis of symmetry is a vertical line passing through the vertex. So if I had a parabola such as this one, the axis of symmetry would pass through the vertex, and it's vertical, meaning it's going up or down. So this would be my axis of symmetry. The next term I'm going to look at is the y-intercept. Y-intercept is the point at which the parabola passes through the y-axis. So if I had an axis here, we'll say this is my x, and this is my y. Okay, if my parabola was situated right here, and goes up like this, then the y-intercept is the point where it passes through the y-axis. So here's my y-axis. It would be this point right here. Okay, so that's where it's crossing the y-axis. X-intercepts then are points at which the parabola passes through the x-axis. So y-intercept passes through the y-axis. X-intercept passes through the x-axis. So let's get a few here. Okay, if I was going to label these my x and y, the y is always the vertical, x is always the horizontal. If I had a parabola that starts down here and goes up, it is going to have two x-intercepts, one at this point and one at this point. That's where it crosses the x-axis. If I had a parabola starting here, there's my vertex, and going up, it is only going to have one x-intercept, and that's the vertex. I could also have a parabola that has a vertex here and opens up. And in this case, there are no x-intercepts. So it doesn't cross the x-intercept at all. So it could have 2, it could have 1, or it could have 0 x-intercepts. The max or min value is just the y-coordinate of the vertex. So let's look at a couple of different parabolas here. Again, we'll label our x and our y-axis. If I had a parabola opening up, let's say the vertex is there, this parabola is going to have a minimum value. And that minimum value is going to be the y-coordinate of the vertex. So here's my vertex. And let's just say this is at -3. And it's going to have a minimum at y equals -3. So when a parabola opens up, it goes up and up and up forever. So there's a minimum value, but no maximum. If my parabola opens downwards, it's going down forever. So it's going to have a maximum value at the vertex. So at this point right here, and we'll say that is 4. So this one would have a max at y equals 4, which would be the y-coordinate of the vertex. So this vertex would be, that's 4, we'll call this -3. So that vertex point would be the point -3, 4. And as you can see, the y-coordinate is your max. For this one, we'll call that 2. So this vertex would be the point 2, -3. And -3 is our min. So the y-coordinate of the vertex is your max or min value. If the parabola opens up, there's a minimum. If the parabola opens down, there's a maximum. Finally, we're going to look at a graph of a parabola and identify the vertex, axis of symmetry, y-intercept, max or min value, and x-intercepts. So let's look at the first one. We're looking for the vertex. So we're looking for the point where the parabola changes direction, which is this point here. If I read my graph, I'm going to go along my x-axis first. So I'm going along the x, and this is 1, and I'm going down 4. So my vertex is 1, -4. And the vertex is always listed as a coordinate, so you need a bracket, the x-coordinate, comma, the y-coordinate, and your bracket. Axis of symmetry. This is the line that's going to cut your parabola right in half. So there's my axis of symmetry. And it's going to look like x equals a value. Now I know this is at the 1, so it's x equals 1. And as you can see, it's actually our x-coordinate of the vertex. So x equals 1. The y-intercept is where it crosses the y-axis. Here's my y-axis, and there's where it crosses right there. Okay, so this is the value y equals, and that's down -3. Maximum or minimum value. Well, does this parabola have a max or a min? It's opening up, and it's going up forever. So it doesn't have a maximum, but the minimum value is right here, and it goes to the -4. So y equals -4, and that is definitely a minimum. Notice y equals -4, that is the y-coordinate of the vertex. Finally, we're going to look at the x-intercepts. That's where it crosses the x-axis, so I know it crosses here and here as well. Now there's two ways you can write this. The first way is writing it as coordinates. So this is the point 1, 2, 3, 0. And there's two x-intercepts. The other one is the point -1, 0. You can also write these as x equals -3, -1. Now you can always ask your teacher which way they prefer, as a coordinate or just as an x value. And there is the basic features of a parabola. If you have any questions, please leave them in the comment section below.